Today, we want to look at another concept under the rules of differentiation called the implicit differentiation. Okay, so before we talk about implicit differentiation, let us quickly look at what is implicit function. For better knowledge of implicit function, okay, we wanted to first look at the explicit form, okay, of what we refer to as this implicit function. So in all our previous video, what we have been discussing is the function of the form y equal to f of x. And what this means is that when we say explicit means this y written separately from f of x. Okay, example of most of these terms, as we have them, okay, we have a function of the form this s squared sine x. Okay, we see that all the expression here, okay, are involve x, okay, which is called the expression of x, f of x like this. Okay, there is no term of y here, and of course, this is the explicit form of function. Also, another form is there are many of them. We are just using only these few ones to. If you have this form, okay, again, this y is written separately from x. Okay, this is an explicit form of function. Now, what do you now mean by implicit function? So, implicit function arises when we mix both x and y together in a given equation. For example, let us use this explicit form to get an implicit form of function. Okay, for y equal to f of x, if we mix these two together, okay, so by writing y, okay, by bringing this f of x to meet y, okay, and of course this will be equal to 0. When f meets y, this will be equal to 0. So this expression that we have here, let us now give it a new name. Let us give it an expression of x and y, okay, and of course this will be equal to 0. This new expression of x and y is what we refer to as implicit function, whose explicit form is y equals to f of x. Okay, so let us pick an example from what we just have here. Okay, so for example, example of implicit function. So we want to make use of one of the thing we write here. So if you are given y equal to the square root of s cube plus 2. Okay, so we want to write this in form of this form. Okay, so that we can call it an implicit function. Okay, so we want to mix both x and y together. How do we mix this? Let us first of all take the square of both sides. Okay, so we'll take the square of both sides, remove the square root so that we have this. Okay, so by now bringing all the term on the right hand side to the left hand side, so this becomes this. Okay, so all of this term now, by comparison, we'll see there's an expression of x and y as we said earlier, and this is equal to 0. Okay, so therefore, the equation y squared minus x cubed minus 2 equals 0 is an implicit function whose explicit form is y equal to the square root of x cubed plus 2. Okay, so there are some implicit functions where to get the y may not be easily available. Okay, but as it may be, okay, so this is how we derive the implicit function from our explicit. Okay, so let us now define what implicit differentiation is. Okay, so if f of s comma is equals 0 is an implicit function. So then the derivative of y with respect to x, okay, but that is the primary aim, okay. The primary aim is to get the y dx, okay. As you can see, we also get this from the explicit form where we always find the y dx, okay. So the derivative of y with respect to x, okay, can be obtained from the following. Okay, so one, we can obtain it in two ways. So the first one is to differentiate f with respect to x. Okay, when we differentiate the left hand side there with respect to x, okay, we differentiate this, of course, this will be 0 since it is 0 here. Okay, we can obtain the y dx from this equation. We can also obtain the y dx from this second equation. Okay, that is if you differentiate partially f with respect to x, here the term dx ds will come, and also when we differentiate this with respect to y, the term dy will come, dy dx will come, and this will equal to 0. So from here we'll see that if we make dy ds a formula, dy ds will be negative di f di x. Okay, so this is what this will give us, the y ds will give us. The first form is this, and the second form is this. Okay, so the symbol die, this symbol is called die, and it means partial. Okay, we normally use it in mathematics, in calculus, where we are dealing with function of two variables. As you can see, this f involves two variables, and of course, to differentiate this variable f with respect to x, we have to be partial. Okay, it is same derivative. Okay, but when we are being partial, okay, we differentiate this while we owe this. Also, we differentiate this while we owe this. That's the partial in it. Okay, so end of these two will give us the slope of this equation. Okay, so let us see some of the examples under implicit function. So the first example, okay, says find the slope dy dx at 0,3 if x squared plus y squared is equal to 9. Okay, so we want to find the slope. Okay, dy dx at this point. Okay, this equation is an equation of a circle. Okay, whose center is at the origin and the radius is 3. Okay, we can look at this this way. Okay, the circle whose center is at the origin 0,0, and then the radius of that is the point from here to here is 3. Here is 3. So the other is 3. Okay, so that's the equation. Okay, I was going to say this is an implicit equation or function, and it is so because this curve is closed. And how do we make it close here? So let f of x comma y be equal to x squared plus y squared minus 9. Okay, as you can see, it is closed. Okay, when it's equal to 0, it is closed. Okay, that's why we are able to. So in this equation now we can form two explicit form. Okay, the two explicit form can form from this equation. Okay, is that 1, that is, since y is having 2 at the top, it means we can obtain two explicit form from this. The first one is, let's make y a formula here. If we make y a formula, this x goes to this side and we take the square root of both sides. So we have this. Okay, so the first y we get is y equals to negative square root of 9 minus x squared, and the second part will be positive 9 square root of 9 minus x squared. Okay, so this explicit form that we'll get here, okay, is this form, okay, which represents the lower semicircle. Okay, this represents the lower semicircle. So you can do this using the normal explicit form to get the derivative of this, and this equation also gives us the upper semicircle, okay, which is also an explicit form of this circle. As you can see, we only have this. Okay, this is not closed, it will be closed. Okay, this is not closed, as you can see. Okay, so as you can see, it is not a complete term, just as we have it here. Okay, so that is it. Okay, and in any of the two, we can take it back to the normal form and become explicit, a complete circle just like this. So if you mark these two, as you can see, you form a complete circle like this. So that is not where we are going. We are only trying to explain both explicit and the implicit function. Okay, so let us see the slope of this using the concept we have described earlier. Okay, so the first concept we describe is to differentiate this part with respect to x, and this will mean the derivative of all the terms here, okay, with respect to x. Okay, and of course equal to 0. Okay, so if we differentiate 0 with respect to x, that will be 0. Okay, so that is not. Okay, so from here, we will apply the sum and difference rule. Okay, since we want to differentiate all the terms here, and each term we differentiate here are with respect to x. Okay, so this can be split into this form. Okay, this means okay, this is what this means. Okay, so that is when we apply the sum and difference rule. Okay, that is the derivative is for each of the terms in the equation. Okay, so here this means we should differentiate x with respect to x. Okay, and that is 2x. And also you will see that this y is a function of x. Okay, and it is also carrying a power 2. Okay, so in order to differentiate this, we will apply what we call the chain rule and the power rule, just like we have discussed that in the previous video. Okay, and this is how it goes. It says in differentiating this, we have first of all applied the power rule, which says this will be 2y. Okay, the power will come down and then remove 1 from the power. Then we'll now differentiate the function itself with respect to the argument. The argument here is with respect to x, so this will be the y dx. Okay, so we're applying chain rule to get this, because this function is also a function of a term. Okay, so this is a constant, now is a constant, so the differential of constant is 0. Okay, so what we have here is let's bring this up. So the next thing is to make the y dx a formula. So now to do that, okay, what we do is we take this term to the other side, okay, and make the y dx a formula. So when we do that, this will be negative 2x all over 2y. Okay, 2y, which is the coefficient of this. Okay, we are bringing it down here. So 2 cancel 2, so this becomes this. So here is the slope of this function. Okay, Here is the slope. At any point of x and y, that is the slope. So now, if we are to evaluate this slope at the point 0, 3, we want to see what will be the slope. The slope will be, that is, wherever we see x, we'll put 0, and wherever we see y, we'll put 3. Okay, and that will be -0/3. Okay, and of course, this will be 0. Okay, so let us see how this behaves on the graph. Okay, so this is the coordinates we have here is 0, 3. Okay, this is 3, 3, -3, -3. So the coordinates 0, 3 is this point. Okay, as you can see, when x is 0, y is 3. So it's 0, 3. Okay, and the slope there, the tangent line that passes through this point is a line this. Okay, and as you can see on the graph here, this line is parallel to this. That's why it is 0. Okay, you can see it is not slopey. Okay, assuming it is slopey, we have a number not equal to 0. Okay, because it's parallel to the horizontal axis, that's why it is 0 there. Okay, so that's how we apply this method to solve problem of a implicit function. So let us see another example. Example 2, we want to find dy dx if x cubed plus y cubed is equal to 6xy. Okay, so solution. Okay, so since we know this will be implicit, because when we bring this term here, everything will be equal to 0, we can similarly differentiate it as it is like this. Okay, what do we mean by this? Okay, is to differentiate this place with respect to x, then differentiate this place with respect to x, and at the end we make dy dx a formula that we are looking for. So we are given this. Okay, so let us differentiate both sides with respect to x. Okay, so again, these two terms are written separately, so we apply sum and difference rule. Okay, which is this is this, and this is this, and of course here we apply product rule because these two terms are together. Okay, so what we note here is that that y is a function of x, and as such we must apply what we call the chain rule and the power rule to find their slope. Okay, so if you have this, we can now differentiate each of the term and see what that gives. Okay, so this is a 3x squared. Okay, so here we apply the chain rule and the power rule here. First of all, we apply the power rule that says 3 will come down. Okay, then we remove 1 from the power, and that's 3y squared. Then, since y is a function of x, okay, we'll now differentiate y with respect to x and multiply it to this term, and that will be dy dx. Okay, so equal to, again, here we'll apply product rule. Product rule says we'll hold this term, okay, first, and differentiate the term at the back. Okay, so if you do that, the term at the back here is y. So when we differentiate y, it is 1. Now, because y is a function of, when we differentiate y is 1, because y is a function of s, so we have to multiply it with the y dx. And this will be this. Okay, then plus, again, we hold y and differentiate 6x. 6x gives 6. Okay, then 6 times y, we have this. Okay, I think that is taken. We have already differentiated y in the first part. So here we are holding y, okay, and differentiate 6x, okay, and of course that x will be 1 there, so that's why we have this. So the next thing is to group this term so that we can find the y dx. So let us group this. Okay, this time has y there, so we can bring this here. Okay, equal to, we have 6y minus 3x squared. Okay, we are taking this 3x squared to the other side to get this. Now let's factor out the term dy dx so that this will be so the next thing is to differentiate to divide both sides by the coefficient of dy dx. Okay, we'll take this to the other side here. So have this. Okay, so this is the slope of the function of an implicit function x cube plus y cube equal to 6xy. Okay, so the slope at any point of x and y. Assuming we are now asked to find the slope of this function at the point 3, 3. So let's see this quickly because it is important we see how these things look like on the graph. So we want to evaluate the slope at 3, 3. Okay, so that is when x is 3, and y is 3. Okay, so the slope, let's see what it will be, and then we'll draw the graph to actually see how slopey is a point or is a tangent line there. Okay, so this will be 6 into 3 minus 3 into, okay, I think we can simplify this further before we do that. 3 goes out here, 3 also goes out here, so this will be 2y minus x squared over y squared minus 6, so minus 2x. Okay, so this will make this simpler to do. Okay, rather than having a very big figure that can lead us to erroneous answer. Okay, let's simplify first. Okay, this is good now. Okay, so let's take it back. Whenever we see y, we put 3. Whenever we see x, we put 3. Okay, so this will be 2 into 3 minus 3 squared over 3 squared minus 2 into 3. Okay, so this numerator is 6 minus 9, and this is 9 minus 6. Okay, so everything here is negative 3 over 3, which is equal to negative 1. Okay, so the slope of this function at 3, 3 is negative 1. Let us see how this look like on the graph. Okay, so let us have a sketch of the function we discussed earlier. Okay, that's this implicit function. Okay, this function, let us see the graph. The graph is this. It's a sketch in any way. For us to have a good drawing, we need to get a good software as well. Okay, this is how the graph of this look like. Okay, so now the point 3, 3 that we have here meet at the edge here. Okay, so if you have a good graph, one can locate the point. This is 3, this is 3. Okay, so meaning we are looking for the slope at this point. So the line which passes through this point is a sloping line that goes this way. And of course, as you can see, this is a negative slope because it is descending. And as we have it here, it is negative 1. So this slope is negative. Okay, so that is it. Okay, so this function has a name, is called, I think in some of the texts, okay, it's called folium of lesser thread or so, or something like that. Folium, whatever. Okay, but this is the shape of it. So let us see whether we should, okay, let us have one more example. Okay, now this example will involve some of the function under trigger identity. Okay, so let us have one more. So 3. So I want to differentiate or want to find the y dx of the function sine x plus y equal to y squared cos x. Okay, so as I've said earlier, we can differentiate this directly since we are sure that this is an implicit function. So it's implicit because when we take this term to this side, everything will go to 0. So it means if you have the graph of this function, it will be enclosed, okay, in a plane. Okay, so let's say solution. Let's do it straight away. So we want to differentiate the right hand side here with respect to x. I want to differentiate the right hand side y squared cos x, okay, with respect to x. Okay, so at the end, those dy dx in the formula will be taken out so that we can get a suitable result, or a suitable slope. Okay, so now, so when we observe that this is a sine of x plus y, which is to do this we apply what we call the chain rule approach. Is because this is an inner function, okay, and according to chain rule says we should differentiate the inner function, bring it out, and multiply with the slope. Okay, so when we do that, so this is written separately, so we apply the sum and difference rule to differentiate the inner function here. So differentiating x here is 1, differentiating y is 1. Because y is now a function of x, so okay, we multiply it with dy dx, as we have said earlier. Okay, so this is 1 plus dy dx. Okay, that is 1 times, that is differentiation, which is 1 times dy dx, we got this. Okay, so when we differentiate cos, sine, we get cos x plus y. So everything equal to. So for this, we apply product rule. As you can see, this is the product of 2 terms. So the first one is y squared. Okay, and don't forget anytime we have differentiating y, okay, we treat it using the approach of the chain rule and the power rule. Okay, and this will be, first of all, we are using product rule. That is, differentiate this, keep this. Then differentiate this, keep this. Let's use that. Anytime we are differentiating this, we should be very careful. Okay, so let's bring y squared first and differentiate cos. This will be minus sine x. Okay, plus, now we are keeping cos. We want to differentiate this. Okay, and of course this will be 2y. Okay, this will be 2y dy dx. And 2y, when we find the power rule, and then when we multiply it with dy dx, okay, using the chain rule, so we'll get that. Okay. So now let us group this term to taking like terms together. So that this will be. So if you expand this and keep the term with you want to keep the term with dy dx here. Okay, let us bring the term of dy dx from here to this side. Okay, so this will be negative 2y cos x. Okay, so let's put in this bracket so that we'll not merge it with this x. So this is 2y cos x dy dx. So everything will be equal to negative y squared sine x. Okay, and again, when we open the bracket here, okay, so we have 1 times this, which is this. Okay, this term has no dy dx, so we are taking to the side. So this will be negative cos x plus y. Okay, so the next is to factor the dy dx out so that we can have the result. Okay, so if we do that, this will be cos x plus y minus 2y cos x, okay, dy dx, and this will be equal to minus y squared sine x minus cos x plus y. So finally, the y dx will be equal to, let's factor the negative out there, y squared sine x plus cos x plus y. Okay, everything will be over the coefficient of dy dx, which is cos x plus y minus 2y cos x. Okay, so here is the slope of the function we have earlier. Okay, so this is how we use or this is how we apply differentiation under the implicit function. Okay, so let us give us some exercises you can lay your hands on at your own leisure time or convenient time. Okay, so let us have some of these. So differentiate out in the following exercises. Okay, you can add this to the wallet that we have earlier by so find dy dx. Okay, find dy dx in the following. So the first one is cos or y equal to y equal to, okay, so let's see. Oh, let's have an implicit type here. Okay, the square root of x plus square root of y equal 1, 2. We want to find 6x4 plus 7y squared equal 9. So 3. We also want to find the implicit term xy equal to the square root of x squared plus y squared. In each of this term, okay, we want to find dy dx. Okay, so what is dy dx? Let's put it this way. What is dy dx in each of this term? Okay, so we can add more and more and more. But for example, let's have 4. Okay. So just be very careful when you are doing this. Okay, because we have to understand the concept very well. Okay, for the approach. Okay, so let's make it 5. Let's make it 5. So sine xy equal to cos x plus y. Okay. So when you finish all this, okay, to confirm whether your results are correct, okay, I'll be sending a Google form in the comment section where you put in your answers, okay, and you will get a feedback whether what you have done is correct or not. Okay, so till we meet in our next class. So let me wish you a goodbye now. Thank you.